Okay, good afternoon, students. Today we are going to see the lecture number 29. Lecture number 29. It is synchronous generator principle of operation. Synchronous generator principle of operation. Okay. So generally we know that the synchronous generator work on the principle of electromagnetic induction. Electromagnetic induction. So what is meant by electromagnetic induction? Electromagnetic induction means whenever a conductor cuts the magnetic flux and EMF is induced, the rate of change of induced EMF is equal to flux linkage. That is E equal to minus N into d phi by dt. Okay, d by dt. What is the electromagnetic induction? Whenever a conductor cuts the magnetic flux, that is whenever conductor cuts magnetic flux, EMF will be induced. Okay, EMF will be induced. Okay, so by using this principle, we are operating synchronous generator on the principle of electromagnetic induction. Okay, and second point, if you take DC generator, there field winding field winding is stationary. Okay, armature winding, or we can say it is a conductor. Armature conductor is rotating. Okay, when if you operate in DC generator. Okay, now if we consider AC generator means, what is AC generator? It is a synchronous generator, or we can say it will be alternator. Okay, so this AC generator, if we operate here, the field is rotating. but armature conductor is stationary. Stationary. Okay, armature conductor is stationary. Now, to understand the concept of principle of operation, to understand the concept of principle of operation, we are consider, okay, we are consider students, my voice is audible, screen is visible. Consider,
Yes, sir.
okay, consider a two-pole alternator. Okay, to understand the concept of principle of operation, consider two-pole alternator. Consider two-pole alternator. Okay, this alternator, which is the single conductor, which is the single conductor. Okay, so in the single conductor, under magnetic field produced by two stationary poles. Okay, so the diagram for this, you can see the diagram. This top and bottom view, or north pole and south pole. Okay, north pole and south pole. So between, I'm going to draw a 90 degree line. Okay, I'm going to draw 90-degree line. Now this is two pole alternator. Okay, two pole. So for every pole there are two pairs are available, so there are four conductors are available. There are four conductors we are placing. Conductor 1, conductor 2, conductor 3, conductor 4. Okay, so this small circle called it as conductor. Okay, the small circle called it as conductor. Okay, because conductors are stationary. Okay, in alternators, in AC alternators. Okay, and this conductor I am projecting in circle type. It will be projected in circle type, and the label of these conductors are 1, 2, 3, 4. Okay, so there are 4 conductors are placed. Okay, are placed. Are you understand? Okay. Now the concept here. Now the conductors starts rotating. Okay, because for every conductor there will be a velocity is produced. Okay, velocity, this line, call it as V. Okay, V stands for velocity. Velocity means, what is the meaning of velocity? It is speed with respect to time. Okay, velocity V. For every conductor there will be a velocity will be produced. Okay, depends upon the direction. For conductor 1 the velocity will be in upward. For conductor 2 the velocity will be towards horizontal line, and for conductor 3 the velocity should be downwards. For conductor 4 it will be horizontal line, but it should be in right hand side. Okay, so this is the conductors velocity direction for 4 conductors. Okay, so this arrow mark call it as velocity. Okay, this arrow mark call it as velocity. Okay, now let the conductor, first point, let conductor means this small circle. Okay, this red color conductor starts rotating from position 1. Okay, this is my position 1. Okay, position 1. So when the conductor starts moving at position 1, your EMF will be sinusoidal wave, right? It is time. It is time. This is induced EMF. Induced EMF. So what is the induced EMF shape in AC? In AC the induced EMF shape should be sinusoidal. It should be sinusoidal. The position which I am marking here, this is 1, this 90 degree, call it as 2, this point is 3, this point is 4, this point is 5. Okay, so the overall it is one cycle. One cycle is how much? This is one cycle, right? Okay, it is 360 degree. Okay, 360 degree. Are you understand? Okay, now let the conductor starts rotating from position 1. Okay, at position 1, during that time the entire velocity velocity means, what is the notation? Velocity v component, because velocity is a component, is parallel to flux lines. Okay, parallel to flux lines. Parallel means you see the velocity for conductor 1, it is moving from bottom to upward, that is downward position to upward position. This is the direction of velocity. Okay, but the flux direction or opposite. This is velocity, but my flux directions are parallel. Okay, that is opposite. This is flux direction. Okay, velocity is parallel to flux. At which position? At position number 1, this position. Okay, this position called as conductor 1. Are you understand? Parallel to flux lines. So therefore there is no cutting of flux lines, because the conductor starts from initial position, right? So there is no cutting of flux lines by the conductor, so therefore the time instant t phi by dt is 0. Okay, 0. Therefore the induced EMF, this position, okay, this position, what is the induced EMF actually in our graph? This position will be 0 point, right? This is 0, this is pi, this point will be 2 pi. Okay, induced EMF in the conductor is 0. Okay, so at the conductor starts rotating from position 1, the velocity component v is parallel to flux direction, that is flux direction means flux lines. Because of this parallel, there is no flux lines or cut by the conductor. Because of this, flux lines are not cut by the conductor, the d phi by dt will be 0. Therefore induced EMF in the conductor is 0. Induced EMF by the conductor is 0. Okay, that is at instant position 1. Okay, this position. Are you understand? Next one. Now as the conductor moves, because now we have to move the conductor, moves from position, this is position 1, okay, position 1 to 2, position 1 to position 2. Okay, so due to here a part of velocity component, you see the velocity it is flowing horizontal. Okay, this direction it's flowing it, this direction, this is the velocity, this direction called velocity perpendicular to flux lines, perpendicular to flux lines. So the part of the velocity component perpendicular to flux lines. Okay, perpendicular to flux lines. Therefore, you see our graph. This is the EMF. It start moving from 1 to 2 because this is 90 degree, right? This is 90 degree. Okay, it starts increasing. So therefore, the EMF, the EMF, therefore, the EMF, this is the EMF. Okay, this line will be the EMF. It start moving from 1 to 2. So the EMF will be increases. EMF increases. Okay, when the EMF increases, as the conductor moves from position 1 to 2. Okay, as the conductor moves from position 1 to 2. Okay, understand? Now, next. Now, as the at the position 2, the entire velocity component is at position 2, the entire velocity, because when the conductor starts moving from 1 to 2 only, a part of velocity component is perpendicular, but at position number 2, the entire velocity component is perpendicular is perpendicular to flux lines. Therefore, there will be a more flux or cut by the conductor. Therefore, the EMF induced is maximum. That is this here, this point. Okay, here, this point is maximum. EMF induced is maximum. Okay, now what is our diagram here? Another, now the conductor, it's start move towards 2 to 3. Okay, it starts move towards 2 to 3. So when it starts moving from 2 to 3, what is the formula? That is, what is the procedure? As a conductor moves from position 2 towards 3. Therefore, the velocity component perpendicular to flux, it starts decreasing. So once the flux starts decreasing, you see the graph. this graph here. Okay, the EMF is also be decreasing. This line, the EMF is also be decreasing. Okay, EMF also decreasing, because in our graph we know this is 1, this is 2, this is 3. So when the conductor starts moving from 2 to 3, the EMF value will be decreasing it. Okay, understand or not? When the conductor starts moving from 1 to 2, the EMF value will be increasing. Okay, the EMF will be increasing. I understand my point. Okay, so now as a conductor, as a conductor, move towards position 3 to 4. Okay, as a conductor move towards the position 3 to 4, say the velocity component, the velocity component is perpendicular to flux, and again starts increasing, but it will be in reverse region. Okay, reverse region means in our graph there will be a reverse region will be there. This is 4. Okay, this region will be increasing it, and again it will be decreasing it. This is 5. Are you understand? Okay, so the positive quadrant and the negative quadrant both are same. Okay, both peak to peak value should be same. This is EMF induced. Okay, so this is the concept of principle of operation of synchronous generator. Okay, principle of operation of synchronous generator. Okay, we know that generator means, we know the basic idea of generator. What is synchronous generator? Generator means what? Which converts? What is generator?
Mechanical into electrical.
Mechanical. No, generator means what it converts? Mechanical into electrical energy. Mechanical into electrical. So there will be a relationship between these two energies, that is in terms of angle. Okay, in terms of angle, because anyway when the machine will be starts rotating at 360 degree, okay, mechanical angle means which is equal to 720 degree 2 times. Okay, 720 degree electrical, 720 degree electrical. Okay, please note down here. If you give 360 degree mechanical, we are getting 720 degree electrical. So what is the relationship between these two? 360 degree mechanical equal to 360 degree into, so how many poles, which I clearly mentioned, how many poles are there? How many poles are there in that diagram?
2.
2. 2 means it is a overall pole. Okay. 2 means overall. But inside how many? For each pole how many pairs? One pair. One pair means two numbers. Okay. So we have to mention P divided by 2. We have to mention P divided by 2 into electrical. Okay. If P equal to 4, 4 divided by 2, how much number of poles you will get? 2 poles you will get it. Okay. So where P is the number of poles. Okay. Therefore, note down, if 1 degree mechanical equal to P by 2 degree into electrical. Okay, in this manner we have to write. Okay, and one more thing, we have to find the frequency, because in our country we are operating 50 hertz. So what is the frequency of induced EMF? One person is entering now. I want to see that person. Chitra. Frequency of induced EMF. Frequency of induced EMF. What is the frequency of induced EMF? Anyone? In terms of cycles, the formula, frequency equal to, frequency means F S, supply frequency. Fs is equal to number of cycle. How much one cycle? How much one cycle? One cycle for how much? It is 360 degree, right? One cycle. One cycle is 360 degree. This is one cycle. This is pi, 2 pi. This call it as one cycle. Okay. So once the number of cycles per revolution into number of revolutions per second, because for every second the cycle value will be vary, because with this with respect to the time t. Okay, so therefore F S equal to number of cycles per revolution P by 2, P by 2 into speed n by 60. 1 minute 60 seconds. Okay, or 1 hour 60 minutes, like that we have to calculate n by 60. Therefore Fs is equal to P n by 2 into 60, how much? 120. 120 hertz. 120 hertz. Okay, so the unit here hertz, or we can mention cycles per second. Cycles per second. Here the n which I am mentioning n, this n call it as rotor speed, unit rpm, revolution per minute, rpm. Understand? Understand or not? Okay. Note, note, a machine bearing a fixed relationship between number of poles, rotor speed and frequency fs is called synchronous machine, and hence alternator are also called synchronous generator. Okay, now what is the synchronous speed? What is the notation of synchronous speed? Because everybody is calling about synchronous means it will be a constant. The meaning of synchronous means constant, okay, or unity. What is the notation of synchronous speed? Synchronous speed notation, anyone? Synchronous speed notation, Lakshmipati. What is the notation of synchronous speed? Lakshmipati. Ns is equal to 120 fs by t, where fs will be the record frequency, that is nothing but supply frequency, 50 hertz. Supply frequency is 50 hertz. Any doubts? Any doubts till now? Have any doubts, students? Have any doubts? If you have doubts, please ask me.